start this recording here. Okay. Start a new note. Oops. All right. Let's get started. Remember way back last week, we talked about exponents and logs. And from now on, I expect you to know those rules and be able to apply them and work with them fluently. Whoa, you never said that. Well, I did, actually. Okay, so we're not going to do any review because from now on, I just expect you. So I told you to go through and do all those practice problems in section 4.1. So if you haven't done that, then just go through and do that. Make sure that you're all good there. Okay, so just in terms of review, we talked about exponents and logs. Okay. I expect you to be fluent in exponent and log rules from now on. Okay. So do all problems in section 4.1 smiley face. Do them all. There's not that many, just to make sure that we're all on the same page, right? And you should just be able to kind of knock them out in less than, I'd say, half an hour or so. I haven't tried them, but should be pretty quick. Okay. So that's kind of what we did last day. We're not going to review it. We'd have to basically do all of last day over again as a review. Okay? That's not how it works. So today, we're starting section 4.2, finally into simple interest. Okay. This is the beginning of our actual, I'd say, business math, right? Where we do, so we deposit some amount of money and it sits there for some amount of time, right? Earning interest. And at the end, we can take it out and we have slightly more than we did when we started, right? And so that's what we're starting from now on, and that's what we're going to keep doing for the rest of the term, okay? Just in different scenarios. So we start with simple interest. Okay. So whether we have an investment or a loan, they behave the same way, right? One, I give money to the bank, right? And when I get money from the bank, right? So if I give money, then I earn interest and they have to pay me interest at the end, right? Or if I get money, so if I get a loan, right, then I accrue interest and I have to pay that back as well as the original amount, right? And so, yeah. Right, and so we have some initial amount regardless of if it's a loan or a deposit, right? And it sits there and it grows for some amount of time. And in the end, we've earned some amount of interest or we owe some amount of interest. So for investments or loans, okay, just in general, how do they work at their most basic form? Okay. So we have a principal deposit earns interest at some specified interest rate or at some specified rate I should say interest rate, sorry. Interest rate for a specified amount of time to yield some amount of interest. So we have a pretty good idea of this, right? Intuitively, we deposit some amount and then we let it grow, and then we can take it out and we have some, our principal amount plus the interest amount, right, that we've earned. Or a loan works the exact same way, but kind of we owe it to the bank instead. Okay, so here, just like before, we're gonna have shorthand notation for all of these things, right? So we're talking about a principal deposit, right? We have some interest rate, we have some amount of time, right? And then we have some amount of interest that we get in the end, right? And so we're gonna say that P, right? P is the principal amount and it's either a loan or a deposit, right? It doesn't matter. And then we said, so it earns interest at some specified interest rate, which we're going to denote by a lowercase r. Right, so this is the interest rate per year. Okay, that's going to be important. That if we're not given per year, so 5% per year, right? If I told you that it's 1% per month, right, then that's 12% per year, right? So we might have to convert it to per year, right? And so that's important to keep track of, right? So it's the interest rate per year. And for the interest rate, I just want to make a note here. We have to use decimals. So even though I said, you know, something like 5%, right, in decimals, that's 0.05, right? So we have to use the decimal version for the interest rate. So then, we have some principal deposit, and it sits there at some interest rate for some amount of time, right? So we let t, lowercase t, is the time in years, or I won't even put that in brackets, it's important. Bless you. The time in years. And then finally, it's going to yield some amount of interest. So we denote that by capital I. Okay. Capital I is the amount of interest. So what we have on our formula sheet, right? First thing in our simple interest section is that I, the amount of interest, equals PRT. So the initial amount that we invested times the rate times however long it was in there for. Seems reasonable enough, right? And so we have this formula on your formula sheet, I equals PRT. I'll throw a little box around it because it's on your formula sheet. Why not? Because I can. Okay. So now we have this formula for calculating the amount of interest. Got a little sloppy here. Almost sloppy again. Amount. I can't win. So this only calculates the amount of interest, right? So this is very basic. This is where we're starting, and then we'll kind of build out, okay? But there's 4 terms in here, right? I, P, R, T. We can use this formula. If we have 3 of these things, we can solve for the 4th one, right? So we're not always just solving for I, right? We can solve for I, we can solve for P, we can solve for R, we can solve for T, right? As long as we have 3 out of the 4, we can solve for the 4th, okay? So as long as we are given information about 3 of these terms, we can solve for the 4th. For the 4th. Let's do an example. Example 132. But I'm going to write it out. If $5,000 interest is earned in 1 year, so you earn $5,000 in interest, that's great. Sign me up. So if $5,000 interest is earned in 1 year at an interest rate of 7.3%, what amount was initially invested? Right, so that's the question. So if $5,000 interest, or $5,000 interest is earned in 1 year at an interest rate of 7.3%, what amount was initially invested? So just like, yeah. Yeah, 7.3. Better-ish. So just like we have been doing, let's start by listing all the things that we've been given, right? And then identify what we have to solve for, right? So here we've been given, okay, so the amount of interest that we have, right, is $5,000. The amount of interest, remember, is capital I. So we know that capital I must be $5,000. Okay. So that's earned in 1 year. So that's the time, right? Lowercase t. T must be 1 year. And remember, t has to be in years. And the interest rate is 7.3%. So the rate is 7.3% or 0.073. Right, we'll use the decimal. And we want to find P, right? What amount was initially invested? That's the principal amount denoted by a capital P. Okay. All right, so far so good. We know the formula I equals PRT. Okay. So we know I is 5,000. P is what we're solving for. The rate is 0.073, and the time is just 1 year. So now we're going to solve for P. We have to divide both sides by 0.073 times 1. That's just 0.073, right? So we get P is 5,000 divided by 0.073. So we have a principal investment of 68,493.15068. I'm just writing out all my decimal places so that you can make sure that your calculator is doing what it should, right? So P is money, right? Your principal amount that you invested. So we have to round to 2 decimal places, right? So P must be 68,493 and 15 pennies. And if you skipped the 5 decimal places to just the 2, that's fine by me. I'm just showing you what to look for. Phew, nice. Wouldn't that be nice? We could just have 68,000. We could invest it for a year. Good luck finding a 7.3% rate. It's usually a little bit lower, but we'd be rich in no time.
1 year cash flow, you guys use right now.
Yeah. We're not going to do questions like that because it's pretty depressing. We're going to have like 12% and 7%. Huge percentages. We're living large here. Okay. So, does that kind of make sense? So we could have taken this formula I equals PRT, right, and just solved for P first because that's the one we want, and then we can just use it over and over again, but you have to solve for it first, right? So, hey, too chatty over here. Thank you. Or we can solve for P in general. Right, if you're reading through the questions and you notice you have to solve for P a bunch of times over, then why not develop the general formula, right, and then work through it that way. I actually prefer to have as few formulas as possible, and I just kind of rework them the way I need them to work, but it's just a matter of preference. So I'm going to show you how to do it. But so we start with I equals PRT, right? If you have to solve for P, you have to divide both sides by R times T, right? So you just hold the P steady and then everything else has to move over to the other side, right? So we could have just went, okay, well, P must be I divided by R times T, and then we can just plug in our values and go from there. Cool. So you could solve for P that way too. Any questions about that one? Either method is good. Well, yeah, they're the same, just different order. So let's do another example. Example 137. Since we're just starting, I've got the first 3 written out, and then the next I'll just steal from the textbook. So Jim's calculations show that the total interest owed to Jill on his $2,700 loan is $315.90. Okay. If he paid simple interest at the rate of 0.9% per month, for how long did Jim borrow the money? So we'll write it out. Jim's calculations show that the total interest Hey, too chatty in the back there. Aren't we a chatty bunch today? Ode to Jill on his $2,700 loan, right? So now he's borrowed money, right? Which means he's going to owe interest at the end. Is $315.90. Okay. If he paid simple interest, at the rate of 0.9% per month, okay, one of those scenarios, right, should be kind of noticing, okay, that rate is not per year, so that's the first thing I need to deal with, right? So per month, for how long did Jim borrow the money? Did Jim borrow the money? What happened to all the money? You guys seen Gail Balzac's shows? Till Death Do Us Part, Princess. Come on, guys. What happened to all the money? Anyways, really good shows. As far as like trashy TV goes, yeah, it's really good. Okay. So, how long did he borrow this money? So we know we have to solve for T, but let's start just like we have always been doing, right? Let's list all the things that we know, also identify what we have to solve for, right? Gives us kind of a clear path. So we know that the initial loan, is $2,700. So that's going to be your principal, right? The principal loan or the principal investment. Okay. And the amount of interest that he's owing at the end of however long, right? So the amount of interest, we're told, is $315.90. So that's your capital I. Okay. If he paid simple interest at the rate of 0.9% per month, so the rate is 0.9% per month, we'll just say that there for now. Okay. And just make a note that we have to find T. Okay. First, need to convert 0.9% per month to a rate per year. Okay. So 0.9% or 0.09, sorry, per month, right? There's 12 months in a year. Okay. Per month is the same as 0.09 times 12, which is a rate of 0.108 per year. Right. So 0.09 times 12. Oops. Okay. I'm missing a 0. This isn't 0.09, it's 0.009. Yikes. Be careful. Because we want to do 0.9 divided by 100. 0.009. I missed one. And it's really because I was just reading it wrong. I have 2 zeros on here. Just didn't write them down. Okay. So I guess be careful. If it can happen to me, it can happen to you. Okay. So now, so R is 0.108 per year. Right. So now we can solve for T, right? So we have I equals PRT. We're told the I, right, is 315.90. P, sorry, we know P was the 2,700, so 2,700. The rate we just decided was 0.108, and T is the one we want to solve for. Okay. So it doesn't matter how we do it. We could multiply the 2,700 by the 0.108 first and then divide them over, or divide them over together and then simplify. It really doesn't matter. Okay. So I'm going to say that T, kind of my go-to move, is 315.90, sorry guys, over 2,700 times 0.108. Right? Just dividing both sides by whatever is multiplying the T. Move it over. And from here, I can simplify first. 2,700 times 0.108, 315.90 divided by 291.60. So 315.90 divided by 291, oops, 315.9 divided by 291.6. So T is 1.0833 repeating years, right? Time is in years. And that's fine for that question. Yeah. Any questions about that one? No? How about another example? Oh, all right. Example 138. So Jess paid interest charges of $169.05 on a $4,830 invoice that was 2 months overdue. Okay. So the invoice was $4,830, and then now 2 months later, right, it's overdue by 2 months. So now she has to pay $169.05 in interest. Okay. What monthly rate of simple interest was she charged, right? So what interest rate makes that happen, right? So Jess paid interest charges of $169.05 on a $4,830 invoice that was 2 months overdue. What monthly, so monthly here, right? What monthly rate of simple interest was she charged? Question mark, I guess. So what do we have here? So we have the amount of interest, 169.05, right? The principal that she was owing, right, when they sent the invoice is $4,830. And the time, right, that it took for $4,830 to accumulate or owe $169 in interest, right, is 2 months. So the time is 2 months. And we want to find R. Yeah, let's map it out here. So we've got first, right, we need to convert the 2 months to years, right, because T has to be in years. So first, convert 2 months to years, right? So T is actually 2 divided by 12 years, right? For this course, we assume that a year has 365 days, 12 months, 52 weeks, right? All those assumptions. So T, we can just leave as 2 over 12, but if we don't want to deal with fractions, 2 over 12, we get 0.16666 repeating, right? So you have to keep all those decimal places, right? So that's why I'm going to just leave it as a fraction, but if you want to figure out how to store stuff on your calculator, we'll get to that probably this week. So now we can use I equals PRT, and just like before, if you have to solve for T or R, right, you can just solve for those in the equation and then plug stuff in, that's fine too. Right. So we have I is 169.05, which is P, we are told is 4,830, times R, which we're solving for, times T, which is 2 over 12. Because the 4,830 times 212, we can just multiply those together and divide them over, or divide them over at the same time, that's fine. Right? So we get R is 169.05 divided by 4,830 times 2 over 12. Okay. So you can simplify 2 over 12 on your calculator, right? Keeping all your decimal places, times 4,830. I get a nice even number. So I get 169.05 divided by 805. 169.05 divided by 805. The rate I get is 0.21. Okay. This is per year. Right. The question, though, asks for what monthly rate of simple interest was she charged. Right. So just like before, if I told you that the monthly interest rate was 1%, right, then we had to convert it to an annual rate. Right. Now we have an annual rate and we have to convert it to a monthly rate, right? So now, convert this annual rate to a monthly rate. So we get 0.21 divided by 12, 0.0175, or 1.75% per month. When you're reporting interest rates, right, you want to report the percentage. If you just left it as a decimal, I'd be fine with it, right? But ideally, take it to that next level and show the percentage. And I guess I should clarify that this is the monthly rate. So some ins and outs, right? But given 3 pieces of information, right, we can solve for the 4th one just like we have, right? We solve for P, we solve for I, we solve for, maybe we didn't solve for I, R, T, can't remember. So long ago. Yeah.
So the timeline says 1.75 per month. Why did we in the first place convert it to years?
Just to be consistent, because I want you to get in the habit of always converting T to years, and the rate has to be in years. And then if you have to take it another step and convert it back to month, then that's fine, right? But I think it's more important that we stay consistent and we say, okay, time is always in years, the rate is always the annual rate, and that's where we start. So yeah, didn't have to, but it's for consistency. Okay. Any other questions? Okay, cool. So 4.3, I'm just going to show you one of the, I don't know, cool features of your fancy calculator that you bought, right? Is that it can calculate the days between dates. So days between dates so DBD on your calculator. Okay. See lecture video around, I guess, 39 minutes in. For instructions. Can't really write this stuff out. Okay. So here we go. It's a little sluggish. My calculator, so zoomed in. All right. Can I do this? I don't think I'm moving, but I guess I'm breathing. Yeah. Here, how about this? I'll try to figure out. We had this last time we had to do this. Thanks. Thank you. Whoa. Need some light on here. Don't know how. Oh, well, I'll just angle it. How about that? All right, good enough. So your how about yellow? I'll turn the lights on. Maybe that'll. Then you can see the calculator, but not see the screen. I think we got it. Okay. So of course, these instructions are in your textbook as well, right? I just want to show you. Okay. And so if I ask you how many days are there between February 20th and September 4th, right? So something like that. Okay. Why would we care about how many days there are, right? For that time, right? So if I say, okay, you invested something on January or February 20th, let's say, right? And then you withdraw it on September 5th, right? How much interest have you made, for example, right? So that's going to be your time component now, right? And so you're going to use the date. I can remember here. So here you have this date function, right? So it's a second function, right? In the yellow up above. I think we all know how to use a calculator that way, right? And so we have this date function that we're going to use. So you're going to go second date. Okay. And you should have, mine's changed because I've used mine, right? You're probably using yours for the first time. So second date, which is the 1 button. Okay. And do you have something that looks like this? So you get dt1 equals, and then I don't know what your date might be. Yeah. So it's going to be some sort of format, day, month, year. I don't know what the default is. What's the default?
It's month, date, and 1990.
Yeah, so yeah, month, day, year. So December 31st, 1990 is the default. Okay. But we can change it. Okay. How we're going to enter it is you're going to go month, month, decimal, day, day, year, year. Okay, so I'll write it down after, right? But for now, if we want to do February 20th, right? So we're going to do February 02, decimal 20th of, I don't know, this year. Doesn't matter what year for this example. Right, so then we're going to do 18. Okay. Looks a little different than what you've seen before, right? And because we have to save it, so to save it, we have to hit enter. Okay. And now it's going to show this same format, yeah. Yeah, so it's going to be, oh, I wish I had that. Okay, so it's going to be month, month, period, day, day, year, year. Right. So if we want to do from February 20th, 2018 to September 5th, 2018. Right. This is going to be your dt1, your date, your first date, right? That's how you read this. That's what it says on your calculator, right? dt1, date number 1, you're going to enter right in the format month, month, dot, day, day, year, year, right? We're going to have 02, and it forgets about the first 0, but you still have to put it in. So 02 dot day, day, 20, year, year, 18. Shouldn't have chosen 20 because it gets confusing. But I guess it's good to see. 2018. How about we do, not the 20th, let's do the 15th. just so it's not so, you see the problem? Don't let that close. Right. Okay. So we enter 0.2 or 0.1518. Okay, so let's change it. So 0.1518. And then to save it, you have to hit enter. Enter is up at the top here, right?
Sorry, but we start with this.
You can just start typing again. So now enter, and it should show you in this format, right? February 15th, 2018. Okay. So now, if you scroll down, right, we have these up-down buttons. So if you scroll down, we can look at, there's a date 2, right? There's a date 2, but also later there's a days between dates. So your second date that you have to enter, right, is going to be, okay, month, so September is 09, day is 05, year is 18. So now we're going to scroll down to date 2, right, and change date 2 to what we have here, right? So we want to do 09.0518. And then to save it, you have to hit enter. Right? Enter. Yeah.
Sorry, I'm a little behind.
It's okay. You scroll down, so you hit this from date 1, you scroll down the down arrow. And then you've got date 2 and you enter date 2. Like this. There's just the 1 decimal, right? And these instructions are in your textbook too, so it's confusing, but just practice a couple of times, you'll get the hang of it, right? So now, if you scroll down to the days between dates, okay, that's my old calculation, but what you're gonna do is you wanna compute this one, right? And so you're gonna use the CPT button, compute. So you're just asking, hey, compute the days between dates. 202. So just like a formula, right? As long as we know 2 of these things and we've entered the 2 of them, right, we can ask it to compute the third. Right, so if you know the start date and how many days later you want, you can find date 2. So let's do some examples. Okay. I'm gonna get rid of this here. All right. So, days between dates. Pretty cool once we get the hang of it. And let's just, as an example, let's do example 139. And I took a picture of it earlier today. I'll change the lights. in theory, you have your textbook in front of you, so it doesn't matter. Example 139, calculate the amount of interest owed on a loan of $3,800, which was advanced on June 17th of 2005, okay, and repaid on October 1st, 2005 at a rate of interest of 10.75%. Wowie. Okay. So let's first outline everything that we know, right? And so we have a principal amount of $3,800. Okay. And now instead of time, right, we have date 1 and date 2. So I'll use the notation that the calculator uses. So I'm going to say, okay, date 1 is June 17th, 2005. And date 2, we're told, is October 1st, 2005. And then we can find, or we're given that the rate, at a rate of interest of 10.75%, or 0.1075. If it doesn't specify per year, then you can assume that it's per year, right? I'll only specify, I'll only have to specify it if it's not per year. Okay. All right, so what do we want to find here? We want to calculate the amount of interest owed. So find I. That's the amount of interest. Right. So first, right, we have to use date 1 and date 2 to find T, right? So first, use date 1 and date 2, oops, to find T. And to show your work for your calculator, right, I want you to set it up just like this. So you're going to have date 1, in the format of month, dot, day, year, right, just as a reminder to yourself what format we need it in. Right. So June is 06. 06.1705. That's your first date. Date 2 is October 1st, 2005. October is the 10th month. First day of 05. And then to indicate that I'm calculating the days between dates, let's just put a little star there, just to say that this is the one that I'm computing. Right. So we have to figure out how many days there are between date 1 and date 2. Right. So we go into our date function. So second date, which is number 1. So second date. Okay. And now we have our date 1 from before, but we can just start typing in a new date and save it. Right. So we just overwrite it. So we want 06.1705. Oops, I mucked up. 06.1705. can't show you because it's kind of tricky, right? But you won't have the date in the format that you're expecting to see it in until you hit enter, right? So we have to hit enter to kind of save it in there, right? And then we can scroll down to date 2 and enter date 2, right? So 10.0105. Again, enter. And you should see 10/01/2005. So now if you scroll down one more, you have the days between dates, DBD, right? If you have to compute this, then even though it says probably 202 from before, right? We can just hit compute and it'll recompute this days between dates with the new date 1 and new date 2. So if I hit compute, I get 106 days. Is that what everyone's getting? So it takes some practice, but pretty fun once you know what you're doing. So T is 106 out of 365 days, right? Because T has to be in years still, right? And so we have 106 days. In terms of years, that's 106 divided by 365 days. Right? So leaving it as a fraction might be easiest. Now we can solve for I. So now we can solve for I. I equals PRT. P was, can't remember, 3,800. R, we were told, was 0.1075. 0.1075. And now T is 106 divided by 365. We're multiplying and dividing, and that's it. So we can do these in any order, and it's still legal. So now we can take, okay, 3,800. Well, let's deal with this 106 divided by 365 first. 3,800 times 0.1075 times 0.290410959 times 0.1075 times 3,800. I must be 118.6328767. Right. So I, remember, is the amount of interest, so it has to be a dollar amount. So only 2 decimal places, 118.63.
So what was the date for this one?
So this one, the date was June 17th to October 1st, 2005. So the amount of interest owing, right? If she got a loan of 3,800 on June 17th, 2005, and then she paid it off October 1st, 2005, the amount of interest that she would have had to pay is $118.63. Okay. It's kind of a lot. Pretty hefty interest rate too. Okay, nice. How about another kind of days between dates example before we keep going? Okay, so I've got example 140. Just so we can get the hang of all this. So on June 26th, we don't know the year, and doesn't matter, we can just make up a year. So on June 26th, what if it's a leap year? Don't worry about it. Exactly. But in general, even if we do pass February, it doesn't matter. Just ignore the leap years. Your calculator takes them into account anyways. So it knows which years are leap years and not. So on June 26th of any year, Laura put $2,750 into a term deposit until September 3rd, when she needs the money for tuition, books, and other expenses to return to college. Sound familiar? For term deposits in the 60 to 89 day range, her credit union pays an interest rate of 4.25%. How much interest will she earn on the term deposit? So how much interest is she going to earn again? Right, so same type of problem that we just did. So let's just outline what we're told. So the first date, right, is June 26th. The second date is September 3rd. Right? So I'll kind of write these not in the order as they appear. I'll keep the dates together. So I'm going to say that the principal that she invested, is $2,750. Date 1 is June 26th, okay, of any year. Say it was this year, 2018. Okay. Date 2, right, is September 3rd, okay, of the same year. And the interest rate that she's getting is 4.25%. Again, it doesn't specify that that's the annual rate, so we can just assume that that's the annual interest rate, and that's fine, right? Or 0.0425 as a decimal. Oh. Okay, so again, we're going to calculate the days between these dates before we can actually find how much interest she earned. Right, so we got date 1. Oh, I'll make a note here. We want to find I. Right. First, find T. Right, T is missing, but we have the 2 dates, so we can find the number of days between them to find T. So we've got date 1. Remember the format: month, dot, day, year. You do have to remember that on your test, and you will have to do this on your test. Date 2. So the first date was June 26th. So June is 06.2618. September 3rd, 2018. September 090318. And then we want to calculate the days between dates, and I'm going to indicate that by a little star. Okay. So here we go again. Going to your date function, so second date, and it'll take you to date 1, which we're going to change now, right, to 06.2618. Enter. Then you can scroll down to the second date, change it, so 09.0318, enter. And then scroll down again to the days between dates and hit compute, CPT. So 69 days between June 26th and September 3rd. So 69 days. So T must be 69 divided by 365, which we can just use in our calculations, right? 69 days, I'll say. So then I equals PRT. I have everything that I need to solve for I, right? So I can say, okay, the P that she invested was $27.50. The rate that she's getting is 0.0425. And the time that she's investing it is 69 divided by 365. So 69 divided by 365. I'll just write it out so you have it, 27.50. If you skip this step and go next to the next one I'm about to do, then that's fine. Okay. So 2750.0425 times 0.189041096 times 0.0425 times $2,750, 22.09417808. So the amount of interest that she's gotten is $22.09. Better than nothing, but not that great. That is true. That is really true. Okay. So the amount of interest that she earned between June 26th and September 3rd would be $22.09. Okay. Cool. Any questions about that? So make sure you go through and practice the days between dates on your calculator, right? Because it's something that I'll expect you to know from now on. Okay. Probably the trickiest part is remembering the format of how to enter the dates, right? So just make a mental note of that. Yeah.
To write the find out T into the test, or just calculate in the calculator and then you write the T.
You have to show this to show me how you got the 69 days. You can't just say 69 days. You have to show this little bit of work, right? Show me that you know how to enter these things and how you got the 69 days. Yeah, big question. All right. So, any other questions? Let's keep going on to 4.4. In 4.4, we're introduced to timelines. And because these things become kind of large, right? So let's say I borrow some money and then I have to, and then I pay some of it off, and then I borrow some more money, and then I have to pay some of it off in some amount of time, right? So these things get kind of bogged down, right? So we use timelines to map out the problem that we have to solve, okay? So we have to get really good at drawing these timelines, right? Because they're how we're going to solve the problem. So timelines. So here we're just going to introduce how do we draw these timelines? What do they look like? Okay. So in general, we have some timeline, right? Now, later, right? In general, here I am now. Here I am later. Hopefully I'm rich. Okay. So we start with our timeline. They're all timeline, but here, right, we have our actual time. Okay. So we have our first date. And then we have our final, what we call the maturity date. Right? So at the end of it all, right, that's the end of our timeline. Okay. And so it's going to be really important that we map these out. Obviously, we don't need to have these little stick men. They're just for fun. Okay. But you do have to have this line, right? And tell me what the dates are at each of these points. So that's your first part of a timeline. And your timelines are actually worth a lot of marks. Say on a 10-mark question, 4 marks for your timeline. Okay? Because it tells me how you're going to solve this problem, right? And so they're a big deal. So you want to make sure that you really nail down and get all of these things sorted out. Okay? So in its most general form, okay, we deposit some P, so some principal amount, and we put it down below. And then with an arrow, we show that this P, sits there. What the? For some amount, sorry. My pen glitched out. Sits there till later, right? Where I don't just have P anymore. I have P plus I, the amount of interest. Right? And then to indicate how long it's been sitting there, I write on this arrow line, I write T. T equals whatever it is. Okay. The only thing that doesn't have a spot here is your interest rate, R. Okay. But I say T equals whatever. Okay. And then write R anywhere on the timeline. Oops. All right, you want to just write down what R is because you'll need to use it for your problem. So often it becomes somewhere like T is this and R is this. We'll do examples. Okay. So we said that later is called the maturity date, right? So it sits there until some maturity date, right? And that's just the end of the investment. So the maturity date is the last date of the term. December 6th in our case. No. That's our school term. Okay. So for a complete timeline, okay, I'll highlight it, right? But you're going to have the time and the actual timeline, right? Until what date? And then the amount that you've invested with an arrow to this, the principal that you invested plus the amount of interest that you've made over some amount of time. Okay. So we're going to draw lots of timelines, and I don't want you to get sloppy. Okay. So we don't really talk about the principal plus the amount of interest, right? we usually just call this the future value. I'm sure you've heard of future values. If not, the future value is just the principal plus the amount of interest that you've earned. Right? So the P plus I is the future value. Okay. And I'll define that later, but I do want to just highlight this here to show the bare bones of your timeline. Must have components of a proper timeline. That's important. So we said, okay, well, the future value is the same as the principal plus the amount of interest. My pen's glitching. Or we can say that the future value is P plus I, like we did up above. That's not the formula on your formula sheet, right? If you look at your formula sheet, you have the future value is P times 1 plus RT. Okay. How we got there is we said, well, we know that I is PRT, right? So we can say that the future value, that's the same as P plus PRT, right? Since I is PRT. And now we've got this common multiple of P that we can pull outside. So this is the formula that we'll use for a future value, P times 1 plus RT. So this little guy is on your formula sheet. I can't remember what the formula sheet color I used was before, but let's use that one. Okay. So now, right, we have the future value. FV is just one thing, right? So don't try to find F or V, it's just FV. So now, same idea. As long as we know one of these 1, 2, 3, 4 things that we need to plug in, right? As long as we know 3 of these 4 things, we can solve for the 4th one. So as long as we know 3 of the 4 terms, future value P, R, or T, we can solve for the 4th. We can solve for the 4th. Okay. Let's do an example. What's this going to look like? So example 141. calculate the maturity value of a $15,000 investment at a simple interest rate of 4.75% after 1.5 years. Okay. So let's see what we're given, and then let's highlight what we have to find. Okay. So we know that the principal investment, right, is 15,000 because we have to calculate the maturity value. The maturity value is the future value. So P is 15,000. The rate, so at a simple interest rate of 4.75, I'm going to start just writing 0.0475. We should be comfortable just writing the percentages in decimals. And T is 1.5 years. Great. So we want to find the future value. So we have our formula. Right, on our formula sheet, the future value is P times 1 plus RT. We want to find the future value. We have P, R, and T, so easy breezy. So P is 15,000 times 1 plus R, which is 0.0475. Times T, which is 1.5. Here we have to be really careful that we're applying BEDMAS, right? Brackets, exponents, division, multiplication, addition, subtraction, right? And so we have to deal with the 0.0475 times 1.5 first, then we can add it to 1, then we can multiply it to 15,000. Okay. So we have 0.0475 times 1.5, writing it out, showing my work, 15,000 times 1 plus 0.07125. Add 1 to that. I'll show all my steps this time. 15,000 times 1.07125. Finally, times that by 15,000. My future value is 16,068.75. Even. I guess I should have done a quick timeline of this when it's kind of this straightforward. Well, I guess it's a good place to start. A timeline. The timeline. Oops. Eek. Would look like this. So we start with our beginning and our end point, right? And we're not actually told the start date or the end date. That's okay, right? We can just say, okay, here we have we can just say now, and then here's the maturity date. That's fine. And then I invested some $15,000 now, right? And so I'm going to indicate that by 15,000 here. Right, so I'm going to take that amount and it's going to grow for 1.5 years. So then I take this arrow here and I draw it from the 15,000 to this point, right? And this, it sits there for t equal to 1.5 years. And I'll just say somewhere here on the side that the rate is 0.0475, right? Just somewhere around there. And we want to find the future value. Okay. Anything you have to solve for, you can just leave it as the variable name on there, right? And then that shows me that, okay, you've read this problem and you actually understand that you've invested some $15,000 for 1.5 years at a rate of 0.0475, and you're looking for the future value, right? If we don't have dates, you can just, we should have dates on here, right? But they can be kind of arbitrary, like now and later, or maturity date, or something like that. Yes, I do. Yeah, for these little basic ones, not necessarily, but ideally you'll do them for all the problems.
We have a basic one like that on the midterm where we say,
Yeah, I'll say include a timeline, or just don't include a timeline, or whatever. If you want to include a timeline, you're always allowed to, right? But if I have to see a timeline, then it'll say include a timeline, right? So how about from this formula, right? If I ask you to solve for P, right, we could just plug into the formula and solve for P that way, right? Or in general, if you have to do it a bunch of times over, right, it might be easier to just find the formula for P, right? And then plug it in. So we might want to solve for P, or R, or T. You can sense the trend coming up, right? So you might want to solve for P. Okay. From the future values, P times 1 plus RT. If you have to solve for P in general, right, then you just divide both sides by 1 plus RT, just move it over, right? And then you're done. So P must be the future value times 1 plus RT. So if you build your timeline and you see that, oh boy, I have to calculate a bunch of P's, right? Then it might be nice to just develop the general formula so you can just plug stuff in to all of them, right? So let's do an example where we have to solve for P. Example 144. Oops. Crooked. What amount should be invested today in order to receive a maturity value of $17,000 in 8 months if money earns 9% simple interest? Okay, so let's draw the timeline for this, right? Even though we could just list everything that we're given, right? Let's start doing it in a timeline instead, right? The timeline is just really listing everything that you're given. So we start with our first date to our second date. So what amount should be invested today, right? So today is our jumping off point. If we want to have a maturity value of 17,000. So now we have any maturity date as long as it's 18 months after today, right, like the question says, we need this maturity value to be $17,000. It's a bit of a reverse from before, right? So now we're saying, okay, we need to take this back to some P, some principal investment, right? And the time here is still 8 out of 12, right? 8/12 of a year. 8 months. Because we're just starting, I'll just do that. Oops. 8 months, or 8 out of 12 years, or year. I want to say plural, but it's less than one. Okay. So by putting that P on there, you're telling me that that's what you have to solve for, right? So you're mapping out what you have to solve for. The future value is 17,000, T is 8 out of 12, and the rate we're told is 9%, so 0.09 simple interest. Okay. Okay. So we have to solve for P. Like I said, I like to have as few formulas to deal with as possible. So I'll just start with the future value formula, right? Not the P that we just developed. Okay. But if you start with the P we just developed, it would be the same thing. So the future value is P times 1 plus R times T. The future value in this case has to be 17,000. We're trying to solve for P times 1 plus R, which is 0.09, times T, which must be 8 divided by 12. So we have to deal with the 8 divided by 12 times 0.09 first before we can add it to 1, and then divide it over to the other side. Or if you want to take all that divided over and then simplify, that's fine too. Okay. So I have 8 divided by 12 is 0.66 repeating. P times 1 plus, and I'm just going to multiply it by 0.09 right away to get 0.06. Plus 1. So I have 17,000 is P times 1.06. Right, simplifying inside the brackets. So P must be 17,000 divided by 1.06. P must be $16,037.74. Just start rounding right away. Nice. So looking back at our timeline then, right, we would have to invest $16,037.74 for it to grow to a total of 17,000 in 8 months at a rate of 9%, sorry. Yeah. Nice. Nice, nice, nice.
When you're writing it down, can you just put it into P equals over?
Totally. Yeah. So, or you can use, right, as long as you've solved for it at once on the test, for example, or on your assignment or whatever, whatever you're working on, as long as you've shown the work for solving for P once, then you can use it. So then the future value divided by 1 plus R times T.
How much work do you want us to show and solve that?
Like this one here. Or
I mean, like solving for P equals F.
well, in this case, it would just be FV equals P times 1 plus RT. Yeah, that's totally fine. Yeah. So either way, pretty easy. Okay. Any other questions? Got one more example here. Example 147. Kind of to show you why timelines are going to be so important. So Okie Dokie Finance Company advanced 3 loans to D. So $2,200 on June 23rd, $1,800 on August 5th, and $1,300 on October 31st. Simple interest at 7.25% was charged on all 3 loans, so the same interest rate. Later on, they're not necessarily the same interest rate even. And so simple interest on all 3 loans, and all were repaid on December 31st. When some bonds that she owed returned. Like that, we have to justify how she's paying it off. She robbed the bank, paid it off. So what total amount was required to pay off the loan? Okay, let's draw out the timeline. See how far we get. Okay, so now, right, it's going to be really important that we keep track of what dates we have to put on this timeline. Right, before we've just been talking today and then later, right, or now and then later, but now, right, I want you to make a list of all the dates that we're talking about, right, and so we're gonna have June 23rd, August 5th, October 31st, and then finally, right, they're all repaid on December 31st. So the first thing you're gonna do is you're gonna map out these 4 dates, right? So our timeline, right, want to give ourselves lots of room here, is going to have 4 dates, and so we need 4 little timeline ticks on here. So it doesn't matter where they go, it's really just to visualize things, right? So I'm just going to space them evenly, even though they're not necessarily evenly spaced. So the first one, the first date here is June 23rd of any year, it doesn't matter. And then we have August 5th, October 31st, and then they're all repaid on December 31st. Okay. So that's the first thing that we have to do to sort out this mess of information. Right? So then she borrows some different sum every time, right? So below each of these dates, you're going to write how much she borrowed, right? Or if she's depositing money, right? Maybe a different scenario, right? Where she deposits money, it behaves the same way. So on June 23rd, she borrowed $2,200. And then on August 5th, she borrowed $1,800. On October 31st, she borrowed $1,300. And then they're all paid off on December 31st. So how we're going to draw these, because all of these, right, if they're all getting paid off at the same time, then all of these yield some future value, right? This one has some future value. This one has some future value, and this one has some future value. And then the total owing is the total of those future values, right? And so because we have all these arrows of future values, right, I'm actually going to start drawing my arrows from the date closest to the maturity date. And you'll see why in a second, because it ends up looking like this, right? I have future value. I'll put a little subscript 1, right? Because I'm going to have 3 future values here and I want to keep track of them. Right? Doesn't matter which subscript you give them. And then this 1800, if I go one line down, becomes future value 2. Right? And this just keeps it nice and clean, or as clean as it can be. And then we have future value 3. Okay. So then here, right, the total of these, if we add future value 1 plus future value 2 plus future value 3, that's the total owing. So here at the bottom, we can do a little sum. So total owing, right? That's the total owing on December 31st. Right? And we'll make a note because we're also given the rate. And like I said, we can just put it anywhere. The rate is 0.0725. Yeah. All right. The future value. So we have to calculate the future value 3 times over. Right. Each of these is going to have a different amount of time. Right. So this line is where the time between October 31st and December 31st, right? So you have to find the days between dates there. Oh, the days between dates here, right? So you have to find the days between dates 3 times. It's a lot of work. Right? And so you're going to write T equals T equals T equals for each of these. So I'll say T subscript 1 equals, we're not going to do it because I don't think we'll have time today. Well, maybe T1, but T2 equals and T3 equals. You don't have to have subscripts on the T's, right? But it's just nice to keep track of. Okay. So we need to find, so that's the end of your timeline. So now you've got everything on here. Once we solve for the days between dates and plug those in, right, this timeline will be complete. Okay. So we need to find, we need to find, days between dates. So for T1, for example, right, date 1 in the format of month, dot, day, year. Date 1 for T1, right, that's our last little October 31st to December 31st. October is 10, right? 10.31. Let's do this year. Doesn't matter. Oops. Or pick your favorite year. Date 2, December 31st. Date 2 is going to be the same for all of these, right? So you can just leave it. Once you enter it once, you can just leave it for the rest of them. So date 2, right, is December 31st. So 12.3118. days between dates. I'll put a little star on there to indicate that that's the one I'm calculating. Right? And so second date function, 10.3118. Enter. Scroll down to date 2, 12.3118. Enter. Days between dates, compute. I get 61 days. So now I can fill that in here. 61 out of 365 years. Right? Because it's days. So for next time, I want you to go through and just finish up this problem, right? Find the T2 and T3, the days between all those dates, and then find the future values, and we'll finish it up next day. Yeah.
You have the answer to the question.
Yes. Yes.
5,450.
I get, it could be a rounding thing, 5,452 and 13 pennies. Nice. All right. See you later.